Hi, this is question 3 from the AQA Further Pure for June 2009 exam paper. In this question we are told that a plane has the equation this here, and this is in parametric form at the moment. For part A we're asked to find an equation in the form r dot n equals d. So we're looking for a general point that when we dot it with a normal we're going to get this constant value of d. So the first part of this question is what we want to do is find out what this normal vector is going to be. So because we know that this and this here are two direction vectors that lie on the plane, we should be able to use this information to find the normal. So what we actually are going to do is we are going to find the cross product of these two vectors, the two direction vectors that lie on the plane. Okay, so right, so you might want to have a go at doing this. Right, so to find the cross product, what I'm going to do first of all is, if I cover up the top row, I'm going to do this number times by this number, take away this number times by this number. So I've got 1 times 1, which is 1, and I've taken away negative 2. So that's going to give me 3. I'm then going to cover up this row. Oops. So that's going to tell me that I'm doing this number times by this number, take away this number times by this number. What we need to remember this time is that we get the negative. We need the negative of that solution. So 3 times 1, which is 3, take away 4 times 2, which is 8. So 3 take away 8 is negative 5. Because we want the negative of that solution, we are going to put a positive 5. Okay, negative of negative 5. Okay, and finally we're going to do 3 times negative 1, which is negative 3, take away the 4, which gives us a negative 7. Okay, so this vector here is going to be our normal. So I can now write down my equation. So this is part A over here. And so far we've got r dot minus 7 equals d. Okay, so we're almost there. Our next task is to find out what this constant value of d is going to be. What we're saying is that any general point on this plane, if I dot it with this vector here, which is our normal to the plane, we always get the same value, and it's going to be a constant value of d. So I need to know what that value is. Because I know it's true for any point on the plane, if I knew a point on the plane and I dotted it with this, that would tell me what that value of d is. Now luckily from here I do know a point on the plane, because I know 2, 1, 1 is going to be a position vector that lies on the plane. So I can now dot that with 3, 5, negative 7. So I've got 2 times 3, which is 6, 1 times 5, which is 5, so I add that on. 1 times negative 7 is negative 7, so I take away 7, and I've got 11 take away 7, which gives me 4. Okay, so that's telling me that d is equal to 4. Okay, so to finish off then, I can now write down what my final equation is. And my final equation is going to be r dot 3, 5, negative 7 is equal to 4. Okay, now just to highlight, I chose 2, 1, 1 for convenience because that happened to be a point that I could quite easily see that lied on the plane, but I could have chosen any point that lied on the plane. So for this case I chose lambda and mu to be 0, and that's why I got 2, 1, 1, but I could choose lambda and u to be 100, so I could say that lambda was 100 and mu was 50, and then that would give me 300, 502, 51 and 251 as a point that was on the plane, and it seems unlikely, but if I now dotted this with 3, 5, negative 7, I should, and I would, still get the value of 4. So you might want to check that yourself. You might want to pause the video and check that yourself. So remember, I can choose any point and I dot it with my normal, and I will always get the same value of 4, anything that lies on the plane. Okay, part B says, just move this over here. Okay, part B says, show that the line with equation this here does not intersect with pi, and explain the geometrical significance of this result. So our first task here is to show that it does not intersect with our plane. Now if I wanted to find, sorry, if I substituted this here in for this here and dotted it with my normal, if it lied on the plane, I should be able to show that it makes that we get a value of 4. If we don't get a value of 4, that will tell me that it doesn't intersect our plane. So I'm going to put this and substitute it into my plane. So my value of my r is going to be 7 plus 10t, and I've got 1 plus t, and I've got 4 plus 5t. Okay, and I'm just writing my my r here as a single vector. Okay, I'm just writing the equation of this line as a single vector. Okay, and I am going to now dot that with my normal, like so, and I'm going to check to see whether I can get a value of 4. So if I stick this in here, I've got 3 times 7 plus 10t plus 5 times 1 plus t, take away 7 times 4 plus 5t. Okay, so that's going to be equal to, and I've got 21 plus 30t plus 5t, take away 28, take away 35t. And I'm now going to go ahead and simplify this, and you might have noticed already what's going to happen here. When I go to simplify this, I've got 21 and 5, which is 26, take away 28, which gives me negative 2. I've then got 30t plus 5t, which is 35t, take away 35t, which gives me 0t, so I get a value of negative 2. Now negative 2 isn't equal to 4. So this clearly doesn't intersect the plane, so we can say that there is no intersection. Okay, last part says explain the geometrical significance of this result. So if I've got a plane and a line and there is no intersection between the two of them, then that tells me that the line and the plane must be parallel to each other. So line and plane must be parallel to each other. Now hypothetically, if we would have got a 4 here, then that would tell me that the line actually lied on the plane, because it wouldn't have mattered what value I would have put in for my parameter. If I always got a 4, then the line must lie on the plane. If I would have got something in terms of t here, well, that would tell me that there was going to be a single intersection point between the line and the plane, and I could actually go off and work out what that point of intersection is. Okay, but in this case the line and the plane were parallel to each other because there was no intersection. Okay, thanks very much for joining me. I'll see you next time.